Welcome to Easy Algebra. Today we're looking at factoring quadratics. A quadratic expression is something in the form ax squared plus b times x plus c, where a, b, and c are numbers and x is our variable. Specifically, what we want to look at today, we want to look at how to factor these. So in factored form, you would have something like this, where here a is actually the same value as we had above. So factoring a quadratic has many uses, and we'll explore those as we go further into easy algebra. But right now we want a method that will work for factoring any quadratic. So we're going to start with a quadratic that has a leading coefficient of 1. And that is x squared plus 7x plus 12. Some of y'all might have seen this. We're going to multiply a and c, and we're going to add to get b. So the ACB method, multiply the leading coefficient and the last value, the constant, and then put the middle value, the b, down below. We need something that will add to give us b and multiply to give us a times c. So here, let's start by identifying our values. Since nothing is shown here, we could put a 1. So here a is just 1, b is 7, and c is 12. So with these values, we know that when we do our setup here, we want something that will multiply to give us 1 times 12, which is 12, and add to give us 7. So we think about things that multiply to give us 12. 1 and 12, 2 and 6, or 3 and 4. Of those, the only two we could add to get 7 are 3 and 4. So now we come back to our original expression, and we're going to take this term and we're going to split it up into 3x plus 4x. We're just taking the values that we found here. We'll bring these down as is. So now we have 4 terms in our expression. We're going to take those first 2 terms and we're going to ask ourselves, what could we factor out? Both terms here have an x. So I could put an x out front and say, what's left? When you divide x squared by x, you get x. When you divide 3x by x, you get 3. If you were to multiply that out using the distributive property, you would get back to what I have underlined in red. We do the same thing over here. What can we factor out of both? Well, they can both be divided by positive 4. When you divide 4x by 4, you get x. When you divide 12 by 4, you get positive 3. And again, if you were to multiply that back out using the distributive property, you'd see that this would become this. So, final thing we need to do here, we see that these are the same, which means we could factor that out as well. So we can make that x plus 3, and then seeing what I've underlined, that's what I pulled out. If I take away what's underlined, what is left? So I'm taking away that, and I'm taking away that. I'd be left with x plus 4. This is the factored form. That expression is exactly equal to x squared plus 7x plus 12, but it's in a factored format. We can do the same thing if we have a leading coefficient other than 1. And this is what I like about this method. So again, we identify a is 2, b is negative 5, the sign goes with the number, and c is negative 3. So if we know our values, we can plug everything in to our ACB method. A times c is negative 6, and b is negative 5. So we need values that will multiply to give us negative 6. So 1 and 6, where one of them is negative, or 2 and 3. Of those, if we did 2 and 3 with one negative, one positive, we would never get 5, because negative 2 plus 3 is 1. 2 plus negative 3 is negative 1. But if we do 1 and 6, one of them has to be negative, so they multiply to a negative. So let's make 6 negative. 1 times negative 6 is 6. This times this gives us that. That works. 1 minus 6 is negative 5, so they add to give us that. So now we know the two values we're going to split this into, positive 1 and negative 6. And you can see that if you were to add those together, you would get negative 5x, so these have the same value as that. Bring these down. And now we're going to go ahead and we're going to work through it the same way we did before. We take the value out front and we say, what can we take out of these? They both have an x. So if I take an x out of both, 2x squared divided by x is 2x, and 1x divided by x is 1. We do the same thing to the next two terms. I could pull a negative 3 out of both of them. So negative 6x divided by negative 3 is positive 2x. Negative 3 divided by negative 3 is positive 1. And again, these are the same. So when you're factoring using the ACB method, we anticipate that those will be the same. So that was our hoped for result. So we'll pull 2x plus 1 out, and we say, what are we left with? So if I'm getting rid of this, and I'm getting rid of this, I'm left with x minus 3. So that is our method for factoring quadratic expressions, whether they have a leading coefficient of 1 or some other leading coefficient.